Okay, in this video we are going to continue with Notes 2 from Calc C, and this is still Taylor polynomials, and if you're following along we're on pages 4 and 5. So what we've kind of discovered is that there's definitely a pattern to Taylor polynomials, and it turns out that the nth degree Taylor polynomial for the function f of x, if we're going to center it at x equals a, which is the most frequently forgotten thing, is given by, I'm using t of x here, sometimes you see p of x, kind of really doesn't matter. You just can't use f of x because it's a polynomial that approximates the function. It's not the function itself. But anyway, it follows this pattern. You always have the nth derivative over n factorial and then x minus a to the n. So if you kind of look, we got it centered at x equals a, so there's always going to be a quantity x minus a. Sometimes it's centered at 0, which causes a little confusion because then you're doing x minus 0 to the n, so no one really writes that, but it's there. So we have 1 factorial, first derivative, first power, 2 factorial, second derivative, second power, and then all the way up to n factorial, nth derivative, and then to the nth power. And now we're just going to use this a couple times. So I'll do one. So we have this table, and we're going to write the Taylor polynomial from the table. So if you look, we're just going to fill in. So first thing is 2, and then plus. So now we're going to go with negative 4 over 1 factorial, and then the quantity x minus, and then don't forget to center it. So the center has to be at 3 because this table gives us derivatives at 3. So it's going to be x minus 3 to the first, plus, and then 5 over 2 factorial, x minus 3 to the second, plus this 8 over 3 factorial, x minus 3 to the third, and then plus 12 over 4 factorial, x minus 3 to the fourth. So it's really easy to write these once you know the pattern and once you've kind of memorized that. So what I'm going to do now is I'm actually just going to show you the answers to the next problems. You can pause the video to check your work, but going through them I don't really think is all that advantageous. Well, actually, this was approximately f of x, so don't forget that. So here we go. On this page, so these are the next 2 problems. These are the answers to the next 2 problems, so you can pause the video and check it out, whatever you want to do. I'm not going to spend much time here, so let's bounce to the next. These are the next 3 problems, which I have totally worked out. So pause the video, take a screenshot, whatever you want to do. Let's move on to the next page. So the next page is going to be page 6, and what you have to remember when you're doing these problems is you always want to make a table. So these problems are a little different. I'm not giving you a table. Instead, I'm giving you additional information, and you can make your own table. So we know that f of 3 equals 2. We know that the nth derivative at 3 is n minus 1 factorial over 2 to the n. We want the 4th degree Taylor polynomial centered at 3. Okay, so what we're going to do is make a table. So n, the nth derivative at 3, and then I need to write the 4th derivative, 4th degree Taylor polynomial, so 0, 1, 2, 3, and 4. Okay, so what happens here, actually, I should have written the problem a little better and said that the nth derivative only applies for n greater than or equal to 1, but I didn't. But if you look at the problem, you're actually told the value of the 0th derivative, because you're told that f of 3 is 2. So that goes right in your table. What is it, 2? And now what I'm going to do is I'm going to plug in n into this formula. So the formula is a little confusing. It doesn't really have anything to do with 3. It's just that it gives you the values at 3. Where do formulas like this come from? I don't know. Some derivatives have patterns. A lot of these, honestly, are just made up. So what I'm going to do is take n equals 1, plug it into that formula up here. I get back 1/2, and that came from 0 factorial over 2 to the first. 0 factorial, remember, is 1. Now I'm going to take 2 and plug it in. That'll give me 1/4, which comes from 1 factorial over 2 squared. Plugging in 3, I get 1/4, which is 2 factorial over 2 cubed. And then plugging in 4, I get 3/8, which is 3 factorial over 2 to the 4th. Generally speaking, by the way, you don't really want to simplify things when you're dealing with Taylor polynomials until kind of the very end, because a lot of things tend to cancel out. So I already simplified these, so I'm going to go with it, but things might have canceled out if I had not done that. So now I'm just going to, I memorized the formula, I'm just going to follow it. So f of x is approximately, so don't forget that approximately equal to sign. Usually you get kind of dinged for 1 point if you write equals, because f of x does not equal what we're about to write. It's only approximately equal to it. And remember, you get a very good approximation around 3, and it gets worse as you get further away. So I'm just plugging straight into the formula, which hopefully by now you kind of have memorized. If you don't have it memorized, these problems are, very difficult. So, all right, and we go all the way out to the 4th degree. In my mind, when something says write the 4th degree polynomial, by the way, because this gets a little confusing later, that means that like an Algebra 2 student would look at it and think that's a 4th degree polynomial. So highest power is x to the 4th, that's 4th degree. All right, let's take a look at some more. So basically the same problem. So now it's at x equals -1, and what we're going to do is make a table. So I almost always, when I'm handwriting these on paper, excuse me, I'll make a vertical table, but here it just makes more sense to have horizontal. Now I'm plugging in, so remember, the 0th derivative is the original function, so I can just plug in 3. And now I'm going to plug in the values of n, so I'm plugging n equals 1, and then 2, and 3, and all go into that formula. So I get -1/4 to the 1st, 1/4 squared, -1/4 cubed, 1/4 to the 4th, and so on. So I'm not really obsessed with expanding those because it doesn't really matter. And now we just straight up plug into the formula. So f of x is approximately, all right, here we go. So 3. So what happens over time is that you start kind of simplifying as you go. So instead of writing -1/4 to the 1st over 1 factorial, I brought that 4 into the denominator already, and I'm going to continue doing that. Now don't forget here, I'm centered at -1, so this is going to be x plus 1 to the 1st, because it's minus -1 to the 1st, and we can just kind of go from there. So once you know the formula, it all just comes down to figuring out all these derivatives, and the problems just kind of give you different ways of figuring out the derivatives. And there we go. That's out to the 5th, which is usually about as far as you go because they're kind of a pain in the neck to write. All right, let's do another one. So 4th degree. This is going to be centered at pi, which is kind of a weird place to maybe center a polynomial. Maybe you might be thinking. You do this a lot with trig functions, though, so pi is not really that uncommon. So the 0th derivative is -3, and then I just plug in. So remember, you're plugging in n, so I plug 1 into the formula, and I get back 2 to the 1/2. I plug in 2, and I get -2, and so on. And then we just plug into the formula that we memorized. So I mean, by now you might really have a hang of this, and you don't really need to be watching. You might not even be watching when I say this, but hopefully you get something out of this. So we have that, and okay, I don't really know what's on the next slide. So yeah, alright, I'm going to stop here. I'll pick up page 7 in the next video because it's kind of a lot of work. So I hope this was helpful, and good luck.